Alright, let's work through this problem, IP validation. This is a problem dealing with a string and breaking it down to its parts, making sure that it works correctly. I'll go ahead and read. Write an algorithm that will identify valid IPv4 addresses in dot decimal format. IPs should be considered valid if they consist of 4 octets with values between 0 and 255 inclusive. Valid input examples would be 1.2.3.4 or 123.45.67.89. And the invalid examples would be these. To talk about them in general, you have one with only 3 parts, one with 5 parts, one that has 4 parts, however one of the numbers is out of the range between 0 and 255. And this last one also has 4 parts, but some of the numbers start with 0. In the notes here, it says leading zeros, such as this example, are considered invalid. Inputs are guaranteed to be a single string. So a 0 alone would be acceptable, but a 0 followed by other digits would not be acceptable. Then we have a bunch of tests here. Let's do what we usually do and delete all of the tests. And we will set up our tests in just a second here. So our first thing we're going to do, we're going to describe what we're doing, which is the name of the function is valid IP. And then we'll do it, saving room for our little message there, setting up our callback, and we are ready to write our first test. Let's go ahead and sketch out some cases. So I'm going to break this problem down in 2 ways. The first, we're going to do cases for the IP address itself. So we know that an IP address, for example, is 34.6.67.132.9. This would be valid or true, in other words. And then we're going to do cases for an octet, and that would be something like 12 is a valid octet, which is true. Oops. However, 256 would give us false. So we will make of this a helper function. So let's put here a note. We're going to do a helper function, and it's going to be called validate octet, with of course a lowercase v. And then up here we have our main function, and that is called is valid IP. All right. We'll move this into a case in just a second, but here's our first case will be 4 octets separated by periods. So this is just our very vanilla case, like this one right here. We have 4 octets. They're all, I could put here maybe valid octets. They're all valid, they're all separated by periods, and we get true. And here's another one, 0, 1, 45, whoops, except for I'm using commas, 45.198. And that would also be true. Then we have less than 4 octets. So they could be otherwise valid if we had 34.78.123, but we only have 3. That's false. We could have something like 1.2.3. That would also be false. We could have 1.020.304. As if they were separated by zeros, that would be false. Then we can have more than 4 octets. So something that would otherwise be valid would be like 34-56-78-12-23. Each one alone is valid, and if we were only looking at that, that would be valid, but altogether, this is false. We could also try something like 45.98.0.1. So this is, again, otherwise valid, except for this trailing dot here. We'll call that false. Okay, that's probably good. Then we can have 4 octets separated by non-periods. We'll call them decimals. Should be called decimals. Kind of the same, but it's a decimal. Okay, so something like 45 semicolon 34 semicolon 12 2. Or, and of course that should be false. Or maybe just one, 67.34.12 comma 98. And that would be false. Okay, let's see, anything else we have? We have less than 4, more than 4, separated by non-decimals. I think that's it, because we have our helper function now to validate the actual octets. So let's start just the same. We'll go with all numbers between, let me put this a different way. Let me say digits only between 0 and 255 with no leading zeros. So those would both be, let's add one more, which would just be 0, and that would be true, true, true. Okay, let's try digits only below 0. So negative 23 is going to be false. And maybe one more. Negative. Now all of these will at least initially be strings, so we'll have to process them accordingly. 29, I don't know. And that would be false. Okay, how about has non-digit characters? And that would be something like 1E2. That of course will be false. My typing tonight is just not there. 2A, as if it was like a 16 base number, is false. And new line 43 would be false. Okay. Digits, oh, I'm going to just move this one here so it's kind of together, but of course we need digits above 255. So 256 is false, and some 3000 number would also be false. Okay, then we need has leading zeros. So first of all, 0 itself is true. We have that case up here, but I'm going to put it here as well, and we can decide if we want to only test it in one of the two places. But 0, 1 is false. And 0 and 56 is false. And just so we don't get a mistake, in fact, let's do 103. That is true. So it's not that we want to eliminate zeros, we just want to eliminate leading zeros, and even then, if it's a leading zero followed by nothing else, it's still true, but if it's a leading zero followed by digits, then that's a problem. Okay, has leading zeros, has non-digit characters, digits above 255, digits only but below 0, digits only between 0 and 255 with no leading zeros. These are the only case that it's actually going to be true. Now, anytime one of these is true, it would also fit in this case up here. Anything else we need to look at here? We're checking for all of the characters. Could we end up with a number that has digits only 0 and 255? I was thinking if we need to check the number of digits, but these two would take care of that. No, I think we're probably good here. So let's start. Now, we can start either way. We could just as easily start with our main function or our helper function. I'm going to go ahead and start with the helper function. So I'm actually going to comment out our main function here. I'm going to write our helper function, which we're calling validate octet. We're passing in our octet, and we are not going to turn anything just yet. I'm actually going to copy this. You've probably seen me do this before in other videos when we're working with a helper function, but I'm just commenting out our main function for right now. In here, I'm going to describe what we're actually testing, which is validate octet. Now we're going to get ready to move our tests over. So we have our helper function here. We use this as our message. We're going to start off with this. It validates digits between, just do digits between 255 with no leading zeros. Okay, so we'll do test.assert equals, passing in validate octet with our number and expecting, now I know we're expecting true, I don't remember exactly what our case is, 12. So we're starting, the reason I'm passing this in as a string is we're starting with a string up here. So either we can convert it before we pass it into the helper function or after. Inside, we'll just handle it inside of here. So let's go ahead and run that. Expected true instead got undefined. And we know how to solve that, don't we? We just want to return true. Let's see if that solves all of our problems. Okay, it does. So let me add my semicolon and copy this, paste this. 0 and 256 are our other answers. 0 and 256. Now, we're testing this very binary example, so just writing true is going to be fine for all of that, and we'll move on to our next block. Very quickly here, we're going to come to cases that need to return false, in which case we obviously will have to write some code. Okay, so we will write it invalidates digits below 0. And we've already done our cases here. We have -23 and -29. Not the most descriptive cases, but they're okay for us right here. So I'm going to delete that, comment out that. We'll use it in just a second. And of course, we would expect this to be false. And let's go ahead and test that. Yep, we're failing. Of course we are. Why wouldn't we be? Now let's write some code. So for this, we can do, let's cast, to start, let's cast our octet to a number. And then we'll say if octet is less than 0, return false. Let's try that. Okay, looks like we're good there. I'm going to comment this one back in. I think our other one was what, -29, right? And we also expect false. Okay, let's get ourselves a little bit of space here. We can always clean up later. So sometimes I write out sort of the instructions, but I'm really just going to follow my tests here and seek to pass all the tests. And then We'll see if we feel like there's anything left to do. Maybe we'll come across something by then. Okay, so let me just copy this, paste this here. And our next one that I just did was it invalidates digits above 255. Okay, our cases are 256 and 3234. So let's do 256 and 3234. I'm just going to write that while it's on my mind, but as always, I do one test at a time. All right, so that test did not pass. No surprise there. We've only got this one condition set up. Let's go ahead and adjust it. If the octet is less than 0 or the octet is greater than 255, return false. Let's try that. Okay. Oh, I don't know what I was thinking here, but hey, always good to write tests for this. 256 is clearly false. And if had I done that right, then I would have had to write some code at the beginning, which would have been a bit better. But let's change it to 255, and it's still true. Let me then change it over here, 255, and we go with that. Okay, looking good. Let's bring this test in. 3234 is going to be false. Okay, no problem there. We can move on to our next case. In fact, let me copy my it block. We are here, invalidates. Paste this in. It invalidates numbers with non-digit characters. All right, get rid of that. Go look at my cases. 1E2. So first of all, what's going to happen when we convert that to a number? Don't know. Here, right, we convert it to a number. Then we check it. Even if something can be notated this way and it converts to a number, it should fall well outside of this range and we should get false. So let's go ahead and test it. Nope, we got true. So it somehow went through. Let's try, for this, I think I'm going to use regex to test for it. So before we convert it to a number, how about we do, I have to think about how this works. It works like octet dot test with the regular expression. I'd have to Google this one. So we want, I think it's like not 0 through 9. So it would be something like if our value includes things other than 0 through 9, return false. But I'm not very confident that I'm doing this right. Let's try if we had something like 3 dot test with the regular expression. The way I put it was 0 through 9. Okay, so that's not right. What if it's the other way around? Which in that case would be like a regular expression dot test to E2. Yes, okay, that looks good. Okay, so you write your regular expression, you call test on it, you pass in the string that you want to test. This is saying, look, if this has any Any value that is, any character rather, that is not 0 through 9, return true, otherwise return false. Now, let me just sketch up a couple more things here. If I have a bunch more numbers and then a letter, then I get true. That looks good. What if I have a space? True. Okay, I think this might bear some more testing, but I think we can work with this. So let me just copy from here. And I'm going to paste it in here. So if this, of course, here we're not going to use that. We're going to put in our octet. And if it has things that aren't 0 through 9, it's going to return true, and then that will return false. So let's test that. Okay, looks good. Of course, we've got a couple more of these to test, so let me go over here. We have 2a equals false. Let me copy this. 2a is false. Looks good. And then here, our last one is new line 43. Test that. Okay, looks good. Let's go on to our next one. Okay, has leading zeros. So invalidates numbers with leading zeros. And let me delete 2 of these cases. We're just going to always work with one test at a time. Okay, 0 alone is true. So let's see how that works. Yep, that looks fine. Now, I think when we're putting the cases together, we discussed whether it's appropriate for that to be there. It's already included up here, so I'm going to go ahead and just delete it from there. If we somehow slide backwards and we break it, we're going to catch it up there above. So 0, 1, and we want to get false here. Oh, we haven't done anything to handle that yet. So, how could we do this? We could do another if statement here, something like if octet at index 0 equals 0, return false. Okay, so that this is exactly what I talked about. Because we already have this test, we see that we're now passing, but we've slid backwards and broken this test. Just thinking about what I want to do here. If I want to cast it to a number first, and then we can look at the length of the number versus the length of the string, or if I want to add another condition here. For example, octet dot length is greater than 1. And because if it is only one number and it's 0, that's okay. It has to be more than one number, and for the first one to be 0. Let's try that. Okay, that works fine. We'll leave it like that for now. Great, go to the next case. 0, 5, 6 is false. So let me go down to here, copy this, paste it up. 0, 5, 6, we expect false. Test that. Okay, good. Last one is 1. This one also is debatable whether we should put this in here, but if we said we want to make sure we don't have any problems with middle zeros, so 1, 0, 3 is true. So it is invalidating numbers with leading zeros, but it's not invalidating an otherwise valid number with a 0 in the middle. Okay, we've now gone through all of the cases in our helper function. So I'm going to go back to these cases. Now I wanted to see, we already sketched out all of the cases before we even got started. So even though we commented out the main function, we had already figured out all the cases before that. So now we can go back here. We're going to bring this function back. And remember, we have our testing block set up here. We're going to bring this back. And we're going to get started there. So our first case is valid for octets separated by periods. It validates for valid octets separated by periods. Wonderful. Test.assert, assert equals rather, is valid IP, passing in a string and getting back. I know our first one is true, whatever we're testing here. Here it is. Okay, now of course it's failing because, good, now we haven't really done anything here yet, but our first couple tests are just setting up a little bit of a foundation that we don't want to slide back and break. Assert equals is valid IP true. And we know it's going to pass, so all good there. All right, let's move on to our second block where we're going to start failing. Less than 4 octets. You know, it occurs to me that we should probably do some false tests here. I don't know why I didn't think to do that, but certainly we should. So let us try 01.45.765.34. And let's actually change this so that we're only failing one thing at a time. Here we're failing because we have 1 beating 0. False. Okay, so let's put that into here. Test.assert equals, I don't know, I'm not, this we need to comment out for now. It validates 4 valid octets separated by periods. Is valid IP, and here we want to get false. Go ahead and test that. Okay, good. Of course it fails, so that's good. Now let's go ahead and sketch out our code here. So the first thing we're going to do, we need to look at each number separately. So let's split on decimal, and then let's loop through octets. Okay, there we go. Loop through octets, and then in each loop we'll validate the octet. If invalid, return false. Otherwise we'll get to the end of the loop and we'll return true. So let's go to there. So we have let octets equals string.split, where we're splitting on the decimal. That should give us, in a regular case, like if we look at, let's look at this first example here, that should give us 34, 67, 132, 9. That's what we should get. Okay, loop through the octets. For let I equal 0, I is less than octets dot length I plus plus. Now this, of course, goes inside of our loop. Oops. If validate octet, and we will use an exclamation mark. So if it is invalid, we will return false, because even one invalid octet would make the whole thing false. So we can just return false from there. Otherwise, return true. So we still haven't looked at whether there's more than 4 octets, less than, or several other things, but this should handle this case here, where this octet is invalid, because it will call this function, it will show that it's invalid, and we'll get false. Let's go ahead and try that. Okay, it looks like it did not work for some reason. So let's look back here. Is valid IP, we expect false. Okay, here's why, because I'm not actually calling it. I need octet I there. Try that again. Octet is not, because it's not octet, it's octets. All right, better. Okay, otherwise it will get through all of them and return true. Wonderful, let's go back. Actually, we've already started this here. Let me comment this out. But we need our next case, which is less than 4 octets. So it handles less than 4 octets. Delete that case. And our next one is here, 34, 78, 123. 123, and this is false because it only has 3. So our loop here is using our helper function, and it should be fine. What we need to check now is if we split this and we only end up with less than 4. So if octets dot length is less than 4, return false. Run that. Okay, it worked fine. I should have run that test before I made the code change, but sometimes you forget. Now check this one out. This one should be interesting. We are copying our test, and then I've got this right here. And what's going to happen here? It has the 3 periods, and it should return false. However, expected false instead got true. How come? Because when you split on something, even if there's nothing after it, it will create an empty string in the array. And then, and we didn't handle empty string here in our validate octet. So stop everything. We need to go back to our helper function. We need to do another test case that we forgot. That I forgot. All right. Hopefully you didn't forget. It invalidates empty strings. So we don't need much of a test here. We just need one empty string and we get false. And we see that it is not working. So on our helper function here, maybe we'll just put it right up top. If octet return false. That is a really easy case that I overlooked. Sadly, I should definitely have caught that, but as we work through things this methodically, even if we miss a case like that, at least we come across it later. Okay, and then here, because this is an empty string now, it does return false. So we fix both with that one. Okay, and then this here, obviously this is going to fail. We'll do test assert equals is valid IP string comma false, and we'll run that. Great. Okay, more than 4 octets. So can't copy this, and we'll paste it. It handles more than 4 octets, where our first one is this here. So on their own, each one would be valid. And let me just comment these two out. Test that. Good, failing as we expect. So let's go back to our main one. If octets.length is less than 4, or octets.length is greater than 4, which of course we just want if octets.length is not equal to 4. Run our test again, and we're back to all green. Next one is this one, same type of thing, where it's actually going to have 1, 2, 3, 4, 5, because this extra period will create another empty string, so it should fail right here as well. Okay, good. We can go ahead and delete this one. I think we've still got one more case. 4 octets separated by non-decimals. So this case is probably trivial. I don't think that we need to handle it for sure, but handles 4 octets separated by non-decimals. But let's do it anyways. So we end up with this, and comment this out, and it's going to be false. Okay, looks good. And our next one is this. It's false. Okay, we went through all of the cases that I could think of here. We've got a good thing going. Hopefully it is sufficiently comprehensive. You always hope for that. Let's delete all of our comments. Well, I should wait and make sure I pass it until I do that, but let's go ahead and test that one more time. Okay, great, and I'm going to go ahead and click on attempt, and we passed it. So you see we got all green tests, means we thought of everything, we handled everything just like we should be. Great time to refactor your code if you want to change anything. I'm pretty happy with the way this is all written here. So I'm going to go ahead and attempt and then submit. Looks good. Obviously, you can find solutions here that are way more compact, though probably harder to read, definitely harder to refactor. And you, as many of these people did, you don't have to write a helper function, but I think this is a prime candidate for the kind of helper function that we did. Thanks so much. Talk to you soon.